Hey, Walter Sorrells back with more tips for the knife maker. Today, some belt grinder tips, specifically 2-inch divot. What is it and how to fix it? So I had a request recently from a Patreon subscriber who wanted to have a little help with 2-inch divot, sometimes called 2-inch bump or some other things. And this is probably the single most difficult problem for new makers to conquer. And I got to tell you something, even guys who've been doing this for a long time sometimes run into trouble with it. So what I'm going to do today is talk about what causes 2-inch divot and how you can fix it. Now I'm actually going to spend a lot more time talking about why and a lot less time showing you stuff on the grinder. I think you'll benefit more by seeing illustrations of this stuff than watching me blast away on the grinder, but I'll probably show a couple things as I go. Alright, so the first issue is what exactly is 2-inch divot? What happens is that when you're grinding the knife, you'll often see that the grind line, which runs across here, will bump up right there, approximately 2 inches away from the plunge line. The ideal when you're making any sort of grind line is that it runs basically the exact same distance from the cutting edge all the way down until it reaches this point. So if you have this little bump right in here, that's considered to be a pretty significant flaw in a knife and something that you really want to avoid. Alright, so I've now turned this around so that it's oriented in the standard fashion that it would be held when you're grinding it. In other words, this is the top edge and you'll be holding it so that that's up on the belt. So let's talk about what causes 2-inch divot. I'm a really big believer that anytime you want to learn how to do something, you're always better off understanding why something is the way that it is. If you don't understand why, you can go around mimicking something that somebody else does to supposedly fix it, and maybe it is something that fixes it, but if you don't understand why, then you can't adapt those techniques into fixing something yourself. So we're going to spend most of this video just talking about what causes 2-inch divot, because it's actually a lot more complicated than it might seem at first blush. This green paper here is representing the platen, the flat platen normally, but it doesn't have to be a flat platen. It could also be the width of your contact wheel. But in any case, this is the width of your grinding belt. As the grinding belt passes across here, if it bites in extra heavy right here, then that's what's going to cause that 2-inch divot to appear right here. There are actually 4 different causes of 2-inch divot there, and I'm going to go into all 4 of them. The first is time, the second is geometry, the third is related to physics, and the fourth is related to some specific issues with respect to certain kinds of belts. So let's start with time. Normally, I mean, at least this is the way that I grind, and imagine here that we're looking, you know, from inside the machine out through the platen as we're grinding, and so we're moving the blade across the platen. So normally what's going to happen, at least this is the way that I do it, is I establish my grind at the plunge line. So I start touching the knife to the belt right here, and then I move the blade across the belt. Now what this means is that if I put it down and immediately start moving, here's how much, let's just say 1001, 1002, 1003, 1004, 1005, 1006. What that means is that at this point you have contact for 0 seconds. 1001, 1000, so right there, 1 second, 1002, 1003, and then so on as we go down to the end of the belt. I mean to the end of the knife. So what that means is that your belt has spent 0 seconds at this point. It spent 1 second at this point. It spent 2 seconds at this point, and it spent 3 seconds here. And if you pull it all the way across to the very end, then it's going to spend 3 seconds on every single piece of the knife from here on out. So all things being equal, what that means is that as you grind, so 0 seconds, 1 second, 2 seconds, 3 seconds, and then 3 seconds all the way across, what's naturally going to happen is it's going to go like this. So it's not going to be square all the way across there, it's going to go like so. And it's going to reach its high point there and stay the same all the way across. Now, nothing wrong with that. That just means you have a very long, smooth, again, all things being equal, long, smooth transition into here. That's not really what causes belt bump though, but it contributes to it. So the second issue is geometry. All right, so imagine that we're looking down from the top of the knife. So the plunge line is right here, and we're going to represent the plunge line here, and this is the blade. So what we're looking at in this little illustration is, just imagine that you're looking at a highly magnified version of that little line right from here, you know, down there. So this represents the plunge line, and that represents the rest of the bevel. So imagine, again, we're blowing this up. This is your 2-inch wide belt. So I'm going to use this. Imagine that this is the face of the belt. So you're coming all the way across like this. And so all things being equal, you're getting equal pressure all the way across there, and you're going to get a nice clean grind. However, what can happen because you have to get to this point and do something with this plunge line, and you have to continually be working this plunge line deeper and deeper. So what happens is, as your belt, as the, you know, the face of the platen climbs up that plunge line, and it can do that in just a fraction of a second. What happens is, and I'm exaggerating here, but as the belt climbs up that plunge line, what happens is that the face of the belt is only contacting the knife at one spot right here. So now, instead of having abrasion all the way across this face, you're only having abrasion right here, concentrated on that corner. So all the abrasive pressure is happening right here. And this right here is the single biggest cause of problems that cause that, you know, right here, it's going to jump up and cause that problem. So you're looking down from above, and that point right there climbs up, and you get that little divot. Let me jump in here to mention that today's video is sponsored by Combat Abrasives. They're a family-owned American manufacturer offering a wide selection of belts. Now, I've used many of their belts, including ceramic, aluminum oxide, and zirconium. The prices are good, and their focus is specifically on the knife-making community. Their basic aluminum oxide belts come in at a good price point and last a lot longer than some of the inexpensive belts that I've used in the past. Another thing that I've really been excited about is their ceramic belts for roughing in the 40, 60, and 120 grit range. Their performance is very competitive with the big manufacturers at about half the price. So check out their online shop by clicking the link in the description. Alright, so just to complicate this issue, there's also an issue of physics here. Your blade has a certain amount of mass, and you're applying pressure on both ends of the blade as you're moving it across the platen. So what happens is, as it hits that little plunge line there, it tends to, the power of the belt, because the belt's running along there at, you know, 1,000 feet per second or whatever, the belt will hit that point and it'll drive the belt, it'll drive the handle part of your knife backwards. Now you're applying pressure to it all this time, and so what happens is that this acts as a little pivot. It pushes this back, and so naturally all of your pressure from this hand forces the pressure this way. And again, it has the same effect. Not only do you have more contact at this point, you also have more pressure. And so all three of those issues, time, geometry, and physics, mean that this area right here is just getting less abrasion than this area right here. So all of that brings us back to this same point again, where we have less pressure here, less time here, less contact with the abrasives, and a little area in here that gets extra contact, extra pressure, extra time, and you get 2-inch divot. One last point that has to be mentioned is that belts are composed of, let me just draw this here. Belts are composed of two layers. So I'm just looking at cross section of the belt. On the back of the belt you have some kind of cloth or plastic material, and then you have on the front abrasives that are suspended in some kind of binder, which is basically like a glue. Now what typically happens, or what can happen especially with cloth belts, is the cloth absorbs a little bit of moisture, and the abrasives and this glue material don't expand, but the back does expand. And so what this does is it forces the edges of the belt forward, and you get cupping, so that your belt has a shape kind of like that. The result of that is that once again, if this is your plunge line and your knife blade, the belt will start to do like this. And so once again, it'll apply a little extra pressure right here, but worst of all, it applies extra pressure here. So just another compounding effect to make time, geometry, physics. You also have this little problem with, it doesn't happen with all belts, but with some belts it does, cloth back belts especially, and you can have that little problem there that just compounds everything. All right, so let me make one more point. If we look through the cross section of any given blade, let's say this is the center line of the blade, and we're ignoring the little secondary bevel here. Every blade has a different angle. With a lot of the blades that I typically make, the included angle here is going to be 8 to 10 degrees, or the angle from the center line is going to be 4 to 5 degrees. That's just typical for the kind of knives that I make. If you're making a chef's knife, let's say you're using stock that's about 0.1 inch thick, or maybe even a little thinner, you may have a blade that's so narrow that you're talking about roughly 1.5 degrees off of axis, or a 3 degree included angle, which is super skinny. What that means is that the thinner that your blade is and the smaller that your angle is, the more it exaggerates the 2-inch divot problem. So if you've never made a blade before and you think, hey, first blade I'm going to make is a chef's knife, just recognize that you're trying something that's extremely difficult to start with. Even really experienced guys are going to wrestle with keeping a really nice high grind line on something like a chef's knife. So if you want that really high grind line on a really thin blade, just recognize that you're going to run into problems here and you may have to fix them by hand later on. You may just not be able to get there from here. All right, so we've reached the point where we've talked ad nauseum about all the things that lead to 2-inch bump. What can we do to fix them? That's the most important thing, right? The first thing that you want to do is when you start grinding, you want to be aware before you ever put the belt to the blade that this is going to happen. This is just natural. All the things that I talked about earlier are going to make this so that all things being equal, you're going to have 2-inch divot. So what does that mean? The first thing that you have to do is start by applying a little extra pressure when you reach that divot, when you reach that plunge line. So in other words, you want to push in a little harder here. So just as you start to grind across here, you're coming into the plunge line, or really it works more like this. Here's your platen. You're going to push in and you're going to apply a little extra pressure right here just from the get-go, because you know it's already wanting to smush you there and mess this thing up. Also, I'm gonna want to dwell here, pause here just a little bit so that I can bite into that corner, establish that plunge line right here. So I'll grind, push in a little extra pressure here, leave it there for a second, trying to keep this edge from not contacting here much at all. Couple more points about this. Once you run into a problem here, just be gentle. Don't panic. Don't get too aggressive. It's easy to run into a problem and then start poking really hard and getting really aggressive with it. Go the opposite direction. Soften up on your pressure. And maybe slow down your grinder. If you've got a variable speed grinder, slow down the grinder a little bit, and just always be working from one end to the other. Even if you could start here or start here, but the general point is, if you try and muck around in here to fix this, you're going to screw everything up. You have to work that entire grind line from one side to the other, and that's what's going to cause it to all even back out. I find that when you just need minor adjustments in your grind lines, 120 grit belts are probably the sweet spot. If you make a mistake with a 30 grit or 40 grit or even 60 grit belt, you can just exacerbate your problems. But if you're up to 120, then it'll move fast enough that you can get things fixed, but it also moves slowly enough that you can kind of control it, and you can spend a lot of time and keep looking at it and messing with it and get it right. Sort of a corollary to that is, don't try to fix your mistakes at 400 grit or something. First, it's too slow, and second, once you start getting up to those higher grits, 320, 400 and belts like that, there's a phenomenon called belt bump, where the little joint in the belt goes ding, 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 ding each time it comes around, and it makes it harder to control the accuracy of your grind at that point. Whereas on 120, typically you're not running into belt bump issues, and so the little 2-inch divot there is a lot easier to clean up. Final point, experiment with your belts. Ceramic belts, just as a for instance, are fairly rigid and fairly flat generally. They don't have that cupping problem as much that I talked about earlier, so they're nice and predictable. They do cut pretty aggressively though, and sometimes that may not suit your style. So another thing you might try are structured abrasives. The nice thing about structured abrasives is that they're fairly forgiving and they don't cut very fast, but when you just need to move your lines a little bit, they can be helpful. So what I'd really encourage you to do is, if you do start running into problems, try out some different belts, experiment a little bit. We talked about that cupping issue. If you're having corners of the belt cut in there, it almost doesn't matter what your technique is, you're always going to have problems there. And so, if you have belts that are really cupped out, maybe that's a brand that you don't want to use, for that, or you want to keep them from getting wet, or experiment with other belts, whatever. It's just something to be aware of. So try different belts and go slow, take it easy, don't panic, and you can fix 2-inch divot. Thanks for watching, guys. If you feel like you got something out of this video, don't forget to subscribe. Also, click on the link to Patreon for a great way to give back to the channel. Plus, check me out on Instagram, Facebook, Twitter. Links in the description. If you want something sharp and pointy, maybe a gift for yourself or one of the cooler people in your life, check out my Tactics Armory website and pick up one of our tactical or outdoor knives. And finally, if you want to learn to make hamones or Japanese swords, check out WalterSorrellsBlades.com, where you can find videos about how I make hamones, as well as forging, mounting, polishing, and fittings for Japanese swords. Thanks, and see you soon.